All right, today we're going to dive into how science is, well, basically re-engineering our food from the inside out to make sure it's safe. And trust me, the whole process is way more complex and, frankly, more fascinating than you probably think. You know the drill. We've all done it. You pick up an apple, or you look at a steak in the supermarket, and you make a quick judgment call. It looks okay, so it must be safe to eat, right? But what if our eyes are actually the worst tool we have for figuring that out? And that, right there, is the crucial point. Real safety isn't something you check for at the very end of the line. It's something that has to be engineered into the food from the absolute beginning. It's all about understanding and controlling everything that happens on its journey to your kitchen. So let's peel back the layers a bit and look at the invisible stuff, the factors that really make all the difference. We're about to step into a world where scientists can control these variables with, honestly, almost unbelievable precision. Okay, so when we talk about the process, we're not just thinking about some simple factory assembly line. Oh no, we're talking about a living, breathing, and incredibly complex biological environment. See, at the very heart of all this are microorganisms. These tiny little living things are just everywhere. And their behavior, whether they grow or die off or just become harmless, is completely dictated by the world around them. So what is that world around them? Well, it really boils down to four key things. Now, time and temperature, we're all pretty familiar with those. But the other two, water activity and atmosphere, that's where the really cool science kicks in. Let's break them down. First, you've got water activity. Now, this isn't just about how much water is in a food. It's about how much of that water is actually free and available for microbes to use. Think of it this way. A microbe can't really drink water that's already chemically bound to something like salt or sugar. So if you can control that free water, you have a super powerful way to stop bacteria from growing. And it's not just about what's in the food. It's also about what's around it. The specific mix of gases, like oxygen and carbon dioxide, can either be a green light for harmful bacteria or a big red stop sign. You know those vacuum-sealed packages you see? Yup, that's atmosphere control right there in action. And the margin for error here is razor thin. We are talking about tiny, tiny shifts. A single degree of temperature, a slight change in that available moisture. That can be the difference between perfectly safe food and a really serious health hazard. The whole system is just incredibly sensitive. So, if the system is that sensitive, how on earth can we manage it all? Well, this is where things get really interesting. This is where we stop being reactive and start being proactive, all by using the power of predictive science. Right. It's the logical question. If you can't see the microbes, and the conditions are always changing, how do you get a handle on it? The answer isn't to just test more at the end. It's to predict better from the start. It's all about building a model. And the tool they use for this is called Predictive Microbiology. It's a really amazing field where food engineers build these powerful mathematical models that can predict, with stunning accuracy, how certain microbes are going to react to those very conditions we just talked about. It's kind of a three-step journey. First, you gather just a ton of data, using sensors and real-time monitoring inside the production environment. Then, you take all that data and use it to build and fine-tune those predictive models, turning raw numbers into actual knowledge. And finally, this is the most important part, you use that knowledge to make real, concrete decisions. And we're talking about decisions that have a massive impact. This knowledge lets engineers define the exact processing conditions they need. It allows them to design entire food systems that are safe from the ground up, and to basically eliminate guesswork and cut down on risk at every single step of the way. And listen, this isn't some sci-fi fantasy. This kind of data-driven approach is already paving the way for the next generation of food production. It's making our food safer and more consistent than it has ever been before. The future is pretty much here. So, does understanding all this stuff open the door to totally new ways of making food? You bet it does. And one of the most exciting examples is a technology that completely depends on this idea of controlling the system. It's called precision fermentation. Get this, instead of, say, raising a whole cow just to get milk protein, you can program a microorganism like yeast to produce that exact same protein inside a bioreactor. You're essentially using these tiny microbes as microscopic factories to create pure ingredients on demand. And it's all happening inside a perfectly controlled, totally safe environment. And this is where it all comes together. A technology like precision fermentation is only possible because we have this deep, data-driven understanding of the biology behind it. Safety isn't an afterthought here. It is literally built into the very design of the system itself. Which, of course, brings us all the way back to the big idea. After seeing all this, it starts to become really clear that the old way of doing things, just spot checking a product at the end of the line, is completely outdated, isn't it? Exactly. The future of food safety, which is really the present, is all about proactive design. It's about a deep understanding of the science, having precise control over all those variables, and literally engineering safety into the system from the very first step. So, the next time you sit down to eat, maybe take a second to think about the invisible world of science and data that made that meal safe. It's kind of a quiet revolution, happening one microbe at a time, that is truly engineering the future of our food.